Hey, today on Rithmetic with Ron, we're going to figure out what do I do if there are two fractions and I'm trying to compare which one's bigger, but they're weird numbers or they're big numbers or small and you can't draw it out. We're going to use long division today and crack that puzzle. Thanks for watching.
Sometimes you will see a problem that looks like this. Let's take 1/4 and let's take 7 out of 25. And what this circle in the middle means is let's pick a comparison, either greater than, less than, or equal to. Which one of these symbols would go in this circle to make this true? Is 1/4 equal to 7 over 25? Is 1/4 greater than, or is it less than? How do we know? We know that 1/4 means, let's see, if we have a pie here and we cut it into fourths, we're interested in 1, okay? But 7 out of 25, that's going to look like a really ugly piece of pie, all chopped up into 25 pieces and highlighting 7. So even though you could do it that way, that's time consuming and you need to be a better artist than I am to do that. So we're going to see today a different way to compare these two fractions. And what we're going to do is we're going to use long division, and we're going to turn these fractions into decimals with long division, and then we can see which decimal is bigger. Let's start with 1/4. 1/4 as a fraction is read 1 divided by 4. So if you say the phrase 1 divided by 4, then you have to write the long division 1 divided by 4. Denominator comes out here as the divisor, and the numerator goes inside the box as the dividend. When we divide, sometimes we have to add a decimal and a couple of placeholder zeros, okay? 4 doesn't go into 1, and now I've got my decimal moved up top so that I keep all my place values in a good place. 4 times 0 is 0. I'm going to subtract, bring down the next 0. 4 goes into 10 2 times. 2 times 4 is 8. I subtract, and I bring down the last 0. And 4 goes into 20 5 times. 5 times 4 is 20. I have nothing left over, and so I'm done. 1 divided by 4 has a decimal equivalent of 0.25. So I'm going to write 0.25 as the decimal equivalent. Let's do the same thing with 7 over 25 and see what happens. 7 divided by 25. Okay, I'm going to add a decimal and a couple of placeholder zeros. I'm going to put 3 in there. I'm not sure exactly how many I'm going to need, but we'll see as we do the problem. Okay, let's move the decimal up into the quotient so that it's in the right place. And 25 goes into 7 0 times. Now let's bring down the 0 here. 25 goes into 70 twice. 2 times 25 is not 20, it is 50. 70 minus 50 is 20. I'm going to bring down the next 0. 200. How many times does 25 go into 200? Well, it goes into 104 times. So 200, it would be 8 times. And 8 times 25, you can check this if you want with a calculator, it will be 200. There's nothing left over, and I'm done. So the decimal equivalent of 7 over 25 is 0.28. Now, instead of trying to compare these two fractions, let's look at these two decimals, okay? Which one of these is bigger? 0.28 is bigger, and so we're going to say 0.25 is less than 0.28, okay? And you can remember that a couple different ways. The less than symbol, it's always going to eat the bigger number, right? Less than and greater than, it's always going to eat the bigger number. The other way that I like to remember it is on the number line. Look at the arrows on this number line that I've drawn. The greater side, the larger numbers are on the right-hand side, and the greater than symbol points to the larger numbers, or the greater numbers. The less than symbol points to the left-hand side of the number line, which is the smaller or the lesser numbers. So either way works. And this is a way that we can compare two fractions when maybe drawing circles or pizzas or pies and trying to shade in parts. This is easy for small fractions, but when you get into the bigger ones, that gets to be a little bit difficult. And this is a great way to compare two different fractions and get some exact answers. One great thing about this method is that it will help you if you run into a tricky problem where you're given fractions that are actually multiples of each other. So let's say that I wanted to compare these two fractions. If you recognize right away that 2/3 and 8/12 are really the same value with different numbers, then good for you. If you don't, that's okay. We're going to go through that same process. We're going to turn each of these into decimals and compare. All right, 2 divided by 3. Let's give ourselves a couple of placeholder zeros, and let's move the decimal point up right away, and we'll start doing our math. 3 does not go into 2, okay, but it does go into 20, and 3 times 6 is 18. I subtract and I get a 2. Uh-oh, I got another 20. 3 times 6 is 18. I get 2 left over. If I were to bring down another 0, this process is going to keep going over and over again. So I know that 2/3 has a decimal equivalent of 0.66 repeating. That repeating bar means that those numbers are just going to go forever. And a repeating bar will repeat whatever is underneath it. So I'm just going to put 0.6 repeating, and that means that there are 6s going out forever. How about 8 divided by 12? 8 divided by 12, let's go ahead and add a decimal and a couple of placeholder zeros and move the decimal up into the quotient so that we keep all of our place values aligned. 12 does not fit into 8. Let's bring down the next 0, but it does go into 80, I think, 6 times. 12 times 6 is 72. Okay, let's subtract and we get 8. Uh-oh, we got the same problem over here. Look at this. Another 6, another 72, another 8. We are getting the same kind of pattern that we saw over here with a repeating number. It's happening here just with larger numbers. And the reason why is because this fraction is actually a multiple of this fraction. And so because they have the same decimal equivalence, we could mark these as equal. They don't look the same, but they are the same. And another quick way to see that, let's take 2/3, and what if I multiply it by a special 1? 3 times 4 is 12, and 2 times 4 is 8. So these, in fact, are equivalent fractions, and they have the same value. So there's a case where using long division to compare fractions will help you to see if you really have the same value, just written two different ways.
So today we saw that long division is a really useful tool if you're trying to compare two fractions where maybe you're not sure, looking at them and even drawing a picture doesn't quite get you there. Long division will work every time by turning that fraction into a decimal. Go ahead and send me any comments. Thanks for watching. Go ahead and hit subscribe, and we'll see you next time.